All right, so welcome to the section on big data and analytics. What we're going to talk about in week 8 is a lot of technology here, especially the newest technologies that are out there based on what's happened in the internet in the last 15 years, and the availability of data, the availability of big storage, big data, search, all these things, social media. So we're going to get into all of that in your readings. This presentation just kind of introduces you a little bit, gets you thinking about what we need to really dig into throughout the course of the week. So we'll talk about analysis and analytics in general, talk about big data, what that means, some key technologies that rest on top of big data and are available because of that, warehousing, search, and then social media. And your book actually does, the Technology for Management does a really good job on some of those technology areas. When we talk about analytics, we are really talking about decisions. That's what we're looking at doing using analytics, is making better decisions. There's a process that's followed. They really in the 60s went through and organized how do people think, and they call this the OODA loop. And it works in combat, it works in arms negotiation, mergers and acquisition, practice patterns, whatever. You observe, you do, you orient, you decide, and act. And whether you're driving down the street and doing the same thing, or whether you're making some big merger decision for the company, you're doing that cycle. And so what analytics does in analysis is helps us perform that cycle quicker. So there's collection for the observation, there's orientation, analysis goes into that, and recommendations that helps you decide. And once you decide on things, then you just let the business take action. So what is an analyst? Well, analytics is basically a method of logical analysis. And an analyst is a person who studies or analyzes. So what is analysis per itself? It's an examination of a complex, its systems, and their elements of that system and the relationship to each other. And when we understand that, that's what analysis really is. So who uses analysts? You got insurance companies, right? They got analysts out there. They have their own mission. You got financial analysts, obviously. And there's marketing. People do a lot of analysis and marketing. Each of these will have different customers. Each of these have different mission. And then each of them will eventually grow into big data as well and use big data as one of the sources of information that they use. There's an analysis process that can be followed. There's lots of different types of analyses. There's statistics. There's data and text mining when you're looking for events that have happened in the past or what they mean. There's model management and deployment. So creating an expectation and then mapping that expectation, whether you're forecasting supply. There's forecasting, there's econometrics, optimization. All these are brought up in your reading. And then intelligence and reporting basically says that once we get this analysis, then we got to do some intelligence and actually get that back out. There's human capital intelligence, meaning basically just smart people. Who are the people we rely on? Financial management, strategy intelligence, supply chain intelligence, understanding what's going on with the supplies that we're trying to bring into our business. To get out of these things, you have to understand query and analysis, how to frame and create questions that will give you information that's useful, how to integrate all of those different analytics into something useful, how to visualize the data in a way that's useful to the business, and then how to manage it at such a level that as you're getting all these different data sets, you basically metadata manage, keep them all time sequenced so that one set of information actually makes sense in the context of another set of information. The world is replete with opportunities that have been missed. So if you look at the analysis that has failed in the past, Montgomery Ward lost out to Sears, right? Sears has lost out to Walmart and Amazon. What is it that Sears knew that Montgomery Ward didn't between 1945 and 1950? And since then, what has Sears basically year over year not been able to catch on to with the changing environment, both with the discount superstores and with the online shopping experience now? The data is out there. Other people are using it. There's nothing keeping you from being able to do that as well. Sometimes the data is out there, and even the best minds, the most highest paid people, can make wrong decisions. If you look at the way Boeing and Airbus have been sort of in a dogfight over the last 20 years, they made a decision in the early 2000s that Boeing looked at the data for where they thought the demographics were going across the globe and said, you know what, people are going to want really big airplanes to fly in. Airbus did. And then Boeing made a decision and said, you know what, people are going to want shorter flights and they're running more fuel efficient. Same set of data, but they made some different assumptions going in, and they wound up with two different answers. One built a 787, which is very successful, and Airbus built a 380, which is broadly considered to be a huge failure. Then they said later, about 10 years later, they said, well, we got a new airplane out there. We need to upgrade those 737s and the A320s that are out there. What should we do? Build a new airplane or just re-engine the same one? Same sets of data. What they come up with? The same interpretation. So what you see there is that they both basically re-engine the new airplanes without building a new one. So you can get the same information out of the data, or you can come up with widely different results. All depends on the quality of the analysis that you're doing. So what you're trying to do is go from gut calls to basically something that's really you can track back to data. Everyone uses data. Even your intuition is really based on data that you've internalized over the year. So you start with data on the left. When you organize the data, it becomes information, something you can use. When you get that information together and internalize it, it becomes intelligence. And once you've got intelligence enough that you can make a recommendation, that's your analysis. Data integrity is a big part of doing good analysis and good data management. What that means is that you've got to make sure that the data itself is scored, it is clean, it is organized in such a way that when you do cross sections of the data, you're getting the same results. So if you get them sequenced by time, you've got them cleansed and enriched. You know, if people are putting in bad data, you can use machine learning to come in and say, well, but they meant to hit this button instead because here's what it said in the text. It's synchronized. You can migrate. You can federate across different bodies of data based on key stores that they have. And you can do master data management. All these things are important and integral to really be able to use the data in an effective way when you're making decisions. And there are data management systems that sit over top of all this. Business typically runs an online transaction processing system, right? Manages all the volatile transaction data. You buy something, it goes through the OLTP. Usually that's going to be a relational database. So your standard databases we've been using for 50 years. Efficient, correct storage processes, SQL kinds of stuff. It's not optimized for online analytics processing, right? Data warehouses are optimized for OLAP. They tend to be no SQL. Higher performance, easily scaled, simpler administration, right? But they have huge data sets, and they'll go through and scan those data sets and come up with results. Okay, not necessarily a specific answer, and that's where it's different. So we'll talk a little about when you use it and when you don't. Alright, so what's big data? Extremely large data sets that can be analyzed computationally to reveal patterns, trends, and associations, especially relating to human behavior and interactions. It's different from small data or medium data in the fact that what it does is it simply emerges from the discussions of these huge data sets that we have now that are so large that can't be used effectively within the existing tool sets. You can't load up the entire history of the internet into an SQL database. It'll crash it. Oracle's not big enough. It's too big to be indexed. It's too big to be distributed across multiples. It's just too big for any of that stuff. And it's too big to then spend the time normalizing all this data into tables and rows. Usually it's unstructured data types. The only way you can deal with big data is to take it as it comes. And so we need take it as you come kinds of technologies. And those have to do with things like Hadoop. Those have to do with big data stores. Those have to do with search algorithms. Those have to do with techniques like indexing, where you look for keywords and you tag those keywords so that when you're searching through there, you can find what you need in terms of results. Is it new? Only sort of. It's a result of a number of changes. One, the increased use of the internet, right? They put a lot of data out there. That drove a lot of people to figure out some things, like what to do with all this big data that was really unstructured because there was no single database running the internet. So now we have technology, we have bandwidth technology, and that makes cloud storage actually viable. So now that cloud storage is viable, people can store things resident someplace else. Well, now there's a market for this technology to be able to do this. Significant availability of storage. I mean, my gosh, the cost of storage has just gone down tremendously. And so all of a sudden, people can look, terabyte of information is nothing, right? New tools then have come about to be able to index and deal with large amounts of unstructured data. Plus, you've got these multi-core processors now. Not necessarily faster CPUs, but they can operate on a lot more data at a time. All of these make the idea of big data possible to be executing across. It's typically not structured. You use basically an indexing process. A lot of times you do multiple passes on the data to go through and index it. Put tags in there, key value stores, that basically assign information to each of those data sets that you can come back and get at later. So you don't have to take the data and make it fit a specific format. You just kind of know what's in it, and then go pull out whatever you need later. Usually you're going to need a lot more storage than you have source data, because the indexing and sometimes the copying and being able to do these rapid searches across Hadoop where you're going to actually copy the data multiple places. So that idea of having cheap data storage is huge, and it's basically a necessity. When do you use it? People will tell you that a cloud, basically, if I have a server, it's my server. If you have a server, it's the cloud. The reality is, cloud basically gives you a lot of ability to extend and expand rapidly your processing. So if you need to do a whole bunch of searches, you can do it in the cloud. It's very difficult to do it on a single server. Huge amounts of data can't be fit and managed in SQL database software. You want to use a cloud for that. You want to use big data. If you need to quickly bring different data sets into the store, no time to normalize everything, use big data. You need tagging, you need store and forward operations, translators. Those are all good purposes. When should it not be used? Number one, if you need fast answers, and by fast answers I mean specific results, it's not great for that. If you don't want to run displays, like something that's going to be a screen, you're tabbing through screens and you're filling out the displays, don't use that. It doesn't support that kind of technology. It's for queries. There's three main levels of analytics that you're going to be using all this for: descriptive, predictive, and prognostic. Descriptive just basically says, I understand the problem, here's what it looks like. Predictive says, I understand the problem and I can see trends, and now I can predict what's going to happen. Prognostic says, not only can I predict it, but I'm so confident of it, I'm building it into my ordering system directly. So now the system is going to do it itself based on what it learns from the data. They gather data in a lot of different ways. There's active ways, you can intentionally go get data. There's passive ways, just data mine, just listen to what's going on. Collect the data from your customers as you're going. 4 V's of analytics that your book talks about you want to know. Variety of sources, the volume, structured and unstructured, velocity, the speed of accessing all those reports, veracity. If it's garbage in, garbage out, then it's no good. You want validated, clean data. Those are the 4 V's of analytics that determine whether it's going to be valuable. And you should know, sometimes enough is enough, Data scientists will say, give me all the data, but the reality is there's still only so much that you can store. So we have to make some decisions and be smart about. Remember, we are still limited in how fast those relationships can be developed and implemented, the programs being built. We have to have analysts to do all this stuff, to build these relationships and write this software. We're still limited in how fast computers can operate to maintain and build those relationships. Unless you have a lot of data that could potentially be collected by different sources. But lack of funding or lack of technology to maintain the relationships in some sort of coherent fashion may prevent you from doing anything useful. I got this example in here. You can go ahead and read it, but basically this talks about how does a restaurant use big data. Each time you go into the restaurant, there's a whole bunch of stuff they learn about you, and they're going to take some actions based on that. So don't think that this is just something for IBM or for General Motors or someone like that, these big companies, Procter & Gamble. This is something that's actually implemented in a lot of different fields. Even small retailers like restaurants use systems that are accessing big data and leveraging those. Also, your commercial programs. When you want to get that competitive advantage, you look at these kinds of benefit programs that are out there and see how they use big data. Airline freight providers, hotel guests, car rentals, online retailers. They know everything about you, it seems like sometimes. But they're doing that because they're trying to make sure that they maximize the value of the customers that they have and maximize the number of customers who are good repeat customers. Search technology, your book's going to go into this. It's key to business. Being able to go through your business information quickly and get at it without having to know 20 different systems. That's a key way to maintain a competitive advantage. Social media also ties you both internally and externally to your customers, but also hooks up your employees within the company. So in conclusion, you got new data sources, you got new technologies, you got new opportunities to gain competitive advantage. We're going to read about all those this week, learn about those, and see when we deploy these to the company, what are the things that are going to bring us the most value.